Hello, it's Dan here. I just wanted to show what I'm doing with the tiny window motor. I've added a half bipolar circuit to it, coming straight off the components into a test board here. The circuit is straight offline. I just copied down off one of Bedini's ones there, drew it down, changed the components. This is just the way that he'd done it. User trigger winding is A and B. A comes onto the pot, into the transistor, through your resistor obviously, and then your B goes down to the base of the other one, which is in parallel with the negative of the battery. Okay, what I've done with the components, I swapped them around a bit because I didn't use what he said as I've gone on with. I used an MJE 3055, I used an MJE 2955T and an MPS A06. All of them were impedance matched. I was going to go a little bit further along with it, or come over and have a look at the board, but what I found is only there's one trigger on the tiny window motor circuit, so I'll need to do Hall sensor triggering or add another trigger winding if I add additional coils to it later on. But at the moment it's just the half bipolar circuit. I disconnected the other two because it didn't do anything anyway. And as you can see here on the circuit, I've made it easy with two red. One comes off just behind the diode from the transistor, that goes on here. The other one comes off the power, goes onto the other side, so that connects to the AC. The output here, as you can see, goes from here to the bottom of this resistor, which all goes through the circuit and is in parallel with ground. And the other one here, which is white, comes off the resistor, so the trigger winding, and that comes on here, as you can see, onto the pot and goes into the circuit. So what I'll do is I'll start it off low, and then I'll see the difference. You'll be able to see as I increase resistance, it will lower the RPM and increase the torque, and then I'll just turn it back and see what we got. So we'll turn on the battery here and see what we got first. Okay. Sorry, on the wrong setting, I have to get the other lead in. Okay, that's more like it. We got 1263. So we'll start it up. For some reason it's self-oscillating now. I'll just plug that one back in again. Must have bumped something. There we go, we got that started. Okay, so we'll let that settle down and I'll talk you through this anyway. So, see a bit over 200 milliamps. I'll turn this up and get it to draw a little bit more. Okay, so at the moment this is a 10 kiloohm pot. I've just turned that right up. And as you can see now, it's drawing a bit over 600 milliamp, way over the C20 rate for this battery. Just come up and have a look here, and we're doing 175, yep, we can see that there, 176 hertz, so we're going quite slow. Then we check the RPM, we're doing 3,500 RPM. A little bit slower even. About 3,500 RPM. And you see the battery here has gone right down because of the amount of current draw on it. So we'll back this one off, and you hear that just picked right up in speed. I dropped about 300 now, so it's about 300 milliamps. The battery's starting to stabilise. Come over here and see the frequency. The frequency's picked right up. It's now doing 316, nearly 317 hertz. A little bit more. I want to take it to about 250 milliamps. There we go, starting to go for it now. You can see here the battery, it's gone to 1240, and it pretty much should stabilise because it's got the energy recovery and it'll sit there for quite a while. And just come around and have a look at our RPM. Which is 6,670, it'll start rising. So as you can see here, we've got quite a good little system, which is quite different, which as you decrease the resistance, the RPM increases and the current draw decreases, which is a nice little opposite. It's a good little motor, has quite a lot of torque. Okay, the battery stabilises a bit more, or self-charging at 1241. I'd say it's just the current draw is stabilised because it's much lower now, because now you can see that it's going to flash. I'll just leave it on for a sec, yeah. Now it's going to normal current draw. So I'll load it down and just watch the meter while I do it. There we go, you can see that meter's gone up to 500 milliamps there, and it took the battery right down. but it's got quite a lot of torque when you do it like that. So definitely some room for improvement with the tiny window motor. You can see here you've got room for additional coils if you want to put them on there on either side. So I'll probably make a stand for it, jack it up, and then I can try putting on a second trigger and get the thing to work as a proper window motor then. Back to 1241, so maybe the thing is just recovering a lot of energy when you load it down. So I hope you like it. It's just my little clip of the tiny window motor. Enjoy, and any questions, post them up. Thank you. Bye.